Hello everyone, and here is an example to express how the thermal expansion converted into stress. Determine the values of the stress in portions AC and CB of the steel bar shown when the temperature of the bar is minus 50 degree Fahrenheit, knowing that a close fit exists at both of the rigid supports when the temperature is 75 degree Fahrenheit. Use the value of Young's modulus 29 multiplied by 10 to the power of 6 psi. The alpha is equal to 6.5 multiplied by 10 to the power of 6 per degree Fahrenheit for steel. Here we have two hinges, and these two pieces or two portions of the steel bar is not allowed to get expansion. But first we have to estimate the amount of elongation, then conversely we will get the stress. First we have to find out whether we have elongation or contraction. The original temperature was 35 and it becomes minus 50. We said when the temperature of the bar is minus 50 degree, knowing that the close fits at both of the rigid supports when the temperature is 75 degree. So this is the starting degree and this is the ending one, minus 50. So we are going to say the change, the difference is minus 50 minus 75. So we have minus 125 Fahrenheit. Then there will be a contraction. The 24-inch will get decreased. So we have a compression contraction here, but in the reverse, as if there is force acting to the right on the joint on the right. The amount of elongation or the strain here, alpha multiplied by delta T. The alpha is 6.5 to the 10 of power of minus 6 multiplied by the difference in temperature, which was 125, will be equal to 0.0008, 0.125. If we multiply it of the bar 24, we have two portions. The first portion is 12 plus 12, L1 plus L2. We'll convert it into contraction force, will equal to 0.0195 inch. This is the shortage of the length. This will be resisted by the support causing B1 reaction. This is divided, actually, this is the summation of the two portions. And we have stress due to the force which was created. The elongation, the first elongation of the first bar is B1 L1 over A1E plus the elongation of the second bar, which is equal to the B1 L2 over A2E. Why B1 and B1? Because we have only single force, but the amount of the force here is B1 and the same force is V1 in the other portion. So the elongation here plus the elongation here will be equal to the total elongation, which is 0.0195, which we have already calculated. So if we are going to add these both together, and we get final equation V1 multiplied by L1A2 plus L2A1 divided by addition of the two areas multiplied by the Young's modulus, and equating it to 0.0195, we will find out that the P1 is 18850 pounds, which is 18.85 kips. The stress in the part AC will be the force divided by the area, and we have the area of the portion EC is equal to 0.6, so we will find out that the stress is 31.4166, while the stress at portion CB would be equal to the same force divided by 1.2, which is the new area. The stress will be 15.70 0.08. We will start talking about the shear stress and shear strain. Thanks a lot and see you next time.